Section 3.4 moves us into our third operation with whole numbers. It's multiplication. And just like the other two sections, we're going to start out with a definition. What do we mean when we say multiplication? So for finite sets A and B, if the number of items in A is A and the number of items in B is B, when n is not 0, n times A means A added together n times. If n is equal to 0, 0 times A is 0. And if we're multiplying A and B together, it really just means counting the number of items in A and multiplying that by the total count of the number of items in B. And that's the same as we saw back in chapter 2 somewhere, where we looked at the Cartesian product and counted those ordered pairs. Okay, there are 4 models for multiplication. So, the first model for multiplication is the one people typically think of when they think of multiplication. It is repeated addition. It mimics that first definition on here very well. A added together n times. Okay? And this is an example of a problem that has a repeated addition feel to it for its multiplication. Giselle takes 3 tests every Friday. After 4 Fridays, how many tests has she taken? Well, she takes 3 this Friday and 3 the next Friday. And we do that for how many Fridays in a row? 4. So we end up adding 3 together 4 times. There's 4 of these. And whether you add or whether you remember multiplication facts at that point in terms of multiplication, facts, I guess is what I want. You end up getting the number 12, right? We do have units because we are talking about a context problem. 12 what? Tests. This is what I feel like about standardized tests right now with my kids. They're on their 3rd set of standardized tests this year. I feel like that's a lot. 3rd set of standardized tests this year, and they haven't even gotten to the state test yet. There will be 4 of them. It's a lot, right? 12 tests is a lot of tests. All right, so Giselle has taken 12 tests. So this idea of repeatedly adding something together multiple times is one perspective of multiplication. Another perspective of multiplication is array. An array model, which is used for sets, notice that specifically. So what does it mean for sets? It means like a countable object of things, right? So you're counting something as opposed to measurement, where we're measuring lengths of something. So we've got menu, and he is baking cookies. He's able to place the dough 3 cookies wide and 6 cookies long on his pan. How many cookies will his pan hold? So even before we got to the description of how he's going to put them on his pan, you already had that picture in mind for cupcakes or cookies, didn't you? Probably you did. And so it says that he has them, how many wide? What was it? Huh? 3 wide. Okay, I'm going to do the 6 long first since I'm going this way for the moment. Okay, so there's 6 long, right? And wasn't it 6? Yeah. And then I'm going to do 3 wide. So I know my dimensions might look backwards to you, but that's the space I've got, so that's what I'm going to do. Okay. And this is how you bake cookies, right? Usually. It is usually how cookies go into the oven to maximize the space on the pan. And you'll notice, this is what's called an array. You'll notice there's the 3 here. And here's the 6 up here. And if you were to count them, or in this essence multiply 6 times 3, how many cookies would they get? 18 cookies. So without saying them out loud, can you think of objects that you typically think of in arrays? Don't say anything out loud, but can you think of some? I gave you an example of cookies, and I slipped and said cupcakes a minute ago too. Right? Cupcakes usually are baked like this too. In fact, the cupcake tins themselves are in arrays. Okay, so when you create your own here in a minute, that's what one of the things you're going to do is you're going to come up with an object that's given in an array, or typically would be thought of in an array, to do a problem with that. All right, the next one is so similar to arrays. It's called area, but it's used for measurement. So it's measuring space on something. And in fact, when you think of area, you probably have that picture already in mind. I'm finding the area of the room, or I'm finding the area of the piece of paper, or I'm finding the area of the square, or the rectangle, or the triangle, right? You have in mind what area looks like. This is rectangular area that we're talking about, so you can draw yourself a rectangle. And it says that Alexis is planting a garden. She has a space that is 5 feet wide. So I'm going to put my 5 here. And 7, I said I was, 5 feet wide. And 7 feet long. How much area does she have in which to plant? So this is 7 times 5. And 7 times 5 is 35. 35 what?
Feet.
Close.
Square feet.
Yeah, square feet. Square feet, and we write it with the squared after the feet. We say it backwards of how we write it. It's kind of like what we do with dollars, right? So we write down a dollar sign at the beginning, and we don't read it till we get to the end. You guys know what I'm talking about, right? Mm-hmm. This is read as not $9, but $9. That's kind of unique, at least. It's not standard across all countries. So the country that my daughter comes from, they would have written it like this. Just so you know. Just so you know. Yeah. That's not a standard operation. I've had to adjust to that when I've had international students myself, because the symbols are in what we would view as the wrong place, but that's just a cultural thing. Anyway, so square feet, the square comes after the feet. So this is what it looks like. Can you think about taking this picture and justifying why that this is actually giving you 35?
Well, if you draw in.
Mm-hmm. You're exactly right, Kaylee. If I drew in 7 rows. Okay, this is terrible because now it's not the right size. We'll try this again. I'll draw my rectangle so it makes it look better. Okay, that'll work. There's my 7 rows. And then I need 5 columns, right? Or 7 columns, 5 rows. I need 7 and 5. Something like that anyway. It's not perfect, but you have the right idea. And what would you do? Yeah, you can count the little squares, right? Sure. So you can justify why this works from a picture perspective, just like you could from the arrays picture perspective. But notice you're counting something different. Here you're counting objects, right? These were individual cookies here. Here you're counting space. So you may feel like that they're similar, and they are. They definitely are similar. But there are nuances to them that make them also feel different. What you're actually finding is slightly different. All right, the last one is the Cartesian Product model. And this is used for ways of choosing objects. So Unique is at a pizza place. She can choose from 2 types of crust, thin or original, and 3 types of toppings, sausage, pepperoni, and ham. How many different types of pizza could Unique choose? So this actually looks like, again, if you've taken proportional and statistical, you'll feel like this feels like something I've done before. And if you haven't, it's not a big deal. But what we do is we first give the choices for the crust. We'll start with crust. So the crust options means that she can choose thin.
Oh, no.
It's okay. Or original. Like so. And after she chooses her pizza crust, she has 3 different types of meat topping that she has choices of. She can choose pepperoni, sausage, and ham. And she has the exact same options if she would have chosen the original pizza. Right? So if you follow along each one of these branches or paths, you can see that you have different choices. The first one is a thin pepperoni pizza. The second one is a thin sausage pizza. The third is a thin ham pizza. Or you can have an original pepperoni pizza or an original sausage pizza or an original ham pizza, right? Those are our choices. How many choices does that give her? 6. There are 6 types of pizza. Assuming these are all the choices she has to make, right? So this is a Cartesian product model. It's used for choosing options when you're given information. So here's what we're going to do with your partner. You're going to find or create an example of all 4 of the types, just the word problem. You don't have to do the work for it, but you're going to create a word problem for all 4 types of our multiplication problems. And once we do that and share, then we're going to stop for today on this lesson, okay? So go ahead and take a look with your partner. All right, I want to make sure we have time for our other group work, so let's push pause right now. If you're not quite finished, it's okay. Can somebody, one group, give me an example of what you did for repeated addition?
Joe plants 3 plants a day for 14 days. How many plants has he planted?
Excellent, we're planting plants. What's an one that you did for array? Something that you thought of as an array. Do you have one, Abby?
Yeah, Bella has a crayon box that is 4 crayons wide and 10 crayons long. How many crayons are there?
Yeah, crayons are like that. Lots of things are in arrays. Soda pop, cans in a grocery store, toilet paper, anything in cylinder form or you big objects like that. There's lots. Baked goods are easy too, of course. We already mentioned those, but there's lots. How about area? What'd you guys have, Lisa?
We said John is sectioning off a playground for his kids. The space is 8 feet wide and 10 feet long. What is the area of the playground?
All right, so we've got the space of a playground. Somebody give me what you have for Cartesian product.
Can we read ours?
Sure.
Okay, Carl is buying a llama and needs a fence that is 20 feet wide by 15 feet long. What is the area?
Okay, so one thing to make adjustments on yours is he doesn't want a fence. He wants a space inside the fence to be a certain way. But otherwise, that's great. He's got a llama that's coming to his house. That's very exciting. My kids would like to come over and pet the llama. We'll do that. Cartesian product. You guys got yours? What do you have?
I didn't write it down yet, but you could say, like, Joe is opening a yogurt shop. He's going to offer 2 types of yogurt, strawberry and vanilla, with 4 topping choices, oats, honey, blueberries, and strawberries.
Cool. And even if you wanted it to be like that, you could describe that and say how many different 1 topping sundaes are there, or like that, so that you've isolated that there's only 1 topping he gets on it from those perspectives. Yeah. Excellent, excellent job. So we'll push pause on this for today and pick up here next time.